You have two input shafts, one for the even gears and one for the odd gears, and you have two clutches, each clutch acting on each input shaft.
With two separate transmission shafts, two gears can be engaged at the same time. To shift, all the car does is switch clutches.
And the shift is then only the change of the clutch system.
The double clutch concept is why the transmission can shift so fast. The car can be accelerating in one gear and already have the next gear ready to go.
It's only possible to do this with an automatic controlled transmission.
Being automatically controlled is not the same as being an automatic transmission. The Veyron double clutch system is really a unique form of a manual transmission controlled by computers.
Compared to an ordinary manual system, the system is quite more sophisticated with its brain behind. So it's a computer brain.
Just for the control unit for the transmission, it's around 4 normal laptop computers.
The transmission isn't only fast, it's incredibly strong. It has to be to handle the extreme forces generated by 1,001 horsepower.
Never before, never ever, in a normal road-worthy car, you have seen a transmission which could shift without brakes in the power. So this double clutch technology was brand new, and at this level of power, nobody has ever done a transmission before in a car.
Even Bugatti engineers are surprised by just how fast the Veyron accelerates.
It's the first time it's absolutely impressive.
0 to 62 miles an hour. That's 100 kilometers an hour in 2.5 seconds.
You don't know what's around you. Your brain is frozen and you feel just this acceleration for 2.5 seconds, and then you cross 100 mark.
That kind of incredible acceleration leads to the next challenge. The Bugatti Veyron will need the most powerful brakes ever built for a street-legal production car. The Veyron has massive disc brakes made from high-tech carbon, ceramic, and titanium. Each brake disc is handmade by experts in Meitingen, Germany, a small town outside of Munich. The raw materials are hand-molded, baked in one oven, polished, baked in a second oven, drilled, and assembled. The Veyron's brakes work at temperatures as high as 1800 degrees Fahrenheit. Normal car brakes stop working at 1300 degrees. But even the Veyron's massive disc brakes aren't enough to handle the car's incredible power. Bugatti engineers face yet another challenge: stopping a car that's traveling at nearly 1/3 the speed of sound. Bugatti Veyron can stop faster than any production car in the world. That's because the Veyron actually has two different braking systems built into the car.
We have the mechanical brakes to the wheels, but we have also an air brake.
At speeds above 125 miles an hour, hit the brake pedal and the Veyron's rear wing shoots up to a 55-degree angle.
It is very helpful when the car is very fast.
The wing acts like an air brake, providing almost a third of the Veyron's total braking power. The air brake alone generates 70% of the braking power of a normal car. Together, the wing and the disc brakes have a total braking force equal to almost twice the force of gravity. The Veyron takes less than 10 seconds to go from its top speed of 253 miles an hour to a complete stop. No other car made has brakes that can do that, or even come close.
You can brake faster than you can accelerate.
2.5 seconds, it needs to accelerate to 100k, and in 2.2 seconds it already has stopped down to 0, which is a very impressive number, I think. It's amazing. Below 5 seconds, the whole thing.
Even more amazing is how the power of the brakes dwarf the power of the Veyron's huge engine.
Deceleration takes about 4,000 horsepower to brake the car from top speed down to 0.
In its up position, the Veyron's rear wing helps braking. Lowered, it adds stability to high-speed runs. The rear wing is a critical part of the Bugatti Veyron, but to control the wing means creating something so fast its speed is almost unimaginable. Speed measured in picoseconds, 1,000 billionth of a second. MTS Sensors is a high-tech company in Lüdenscheid, Germany, about 100 miles northwest of Frankfurt. It's here where they build a remarkably tiny sensor unit for the Veyron's rear wing.
It is the fastest piece in that car.
The sensor measures the time it takes a pulse of light to travel down a wire, hit a magnet, and reflect back as an ultrasonic sound wave.
The sensor performance has to be not only correct, but also has to be quick enough that the computer system in the car can execute the right angles on the wing as needed.
For normal driving, the wing is retracted. Hit 136 miles an hour, and the wing pops up to a 15-degree angle. For high-speed runs above 230 miles an hour, the wing retracts to just 2 degrees. And for high-speed stops, the wing hits 55 degrees in 0.4 of a second. The Veyron adjusts its aerodynamic configurations on the fly. Without the tiny sensor in the wing, the car would never be stable enough at 253 miles an hour. And it would be even worse if it did go that fast. Without the tiny sensor in the rear wing, the car could never safely brake from that speed.
Without the sensor controlling the wing and the computer knowing the information on the wing and varying the angles on the wing, they would not have been able to do that.
Each sensor is handmade. A wire half the thickness of a sewing needle carries both the light and sound waves. A tiny magnet is welded to the wire under a microscope. Everything about the sensor is remarkably small.
The weld is 1/10,000th of an inch. It's a very small weld.
The sensor is tested, sealed inside a weatherproof housing, tested again, and then packaged for shipment to Hegemon Aerospace. A company that specializes in making parts for jets and rockets. They install the sensor in the strut assembly for the Veyron's rear wing. Then, it's checked on a machine made just for the Veyron to make certain both sensor and wing work perfectly.
The rear wing is a good sample for the combination of automotive and aerospace, because this hydraulic system could also drive a flap system in an aircraft wing.
Hegemon Aerospace builds 150 sub-assemblies for the Veyron, including the rear and front frames for the car. They construct the rear frame out of high-strength aircraft-grade stainless steel and weld it exactly the same way they weld airplane parts.
All welders doing any kind of work on this car are certified aircraft welders.
It takes a lot of time, and that's one reason the rear frame is one of the most complicated and expensive parts of the entire car.
It takes around about 80 to 90 hour handcraft work to produce this single part here.
Hegemon Aerospace also manufactures the Veyron's fuel tank.
From the first design to finish 4 years.
It took that long because the Veyron's fuel tank needs to pump fuel 8 times faster than a normal fuel tank. It takes 3 days to weld together the fuel tank for the Veyron. $250 different parts. 5 times the number in a normal car's fuel tank. There are 2,300 different parts in all the Veyron sub-assemblies Hegemon Aerospace manufactures. One of the key parts of building the Bugatti Veyron would be something most people take for granted, but not Bugatti.
At the end, one of the key points was the tires.